All right, Precalc students, we are going to solve this system by finding a row echelon form. So if you remember from class, allowing our calculators to do reduced row echelon form for us is much easier, and I'd highly recommend that when solving a system. However, for the sake of practice and understanding the connection between matrices and row operations and reduced row echelon form, we are going to put this system into row echelon form using some matrix operations. So here's the things I would like to go through. First of all, we are going to create our augmented matrix using the numbers that are from the system. So those would be my x coefficients. Here's my y coefficients. And my z coefficients are going to go in this column. And then finally the constants in a fourth column. So -3 and 0 and 7. All right. So we're going to try and eliminate a variable. Row echelon form, we want ones on the main diagonal and zeros in the preceding spots of row 2 and row 3. Numbers here, that's fine, that's okay. So let's try and get rid of this 2 in row 2 first, shall we? So what we're going to do is we're going to multiply row 1 by probably -2, if you think. So we're going to go -2 times row 1, and we're going to add that to row 2. So that would be the step that we would take to transform our matrix. So what's going to happen is it's going to look like this. So row 1 is going to stay the same. Didn't change anything about row 1. Well, row 2 is going to be different, because what we're going to do is we're going to multiply each item in row 1 by -2 and then add it to row 2. So -2 times 1 is -2, plus 2 is 0. There's my new number there. -2 times -1 is going to be +2, plus the 1 is going to be 3. -2 times 2 is -4, plus -1 is -5. And -2 times -3 is 6, plus 0 is going to be 6. Check my numbers. I think I got that right. Yep. All right. And then row 3 again didn't change. So -1, 2, -3, and 7. Next step, let's work on row 3. Now I think that just combining row 1 and row 3, like adding these together, that'll eliminate the x, which is nice. So that'll be our next step. I'm going to rewrite it down over here. So little arrow, this is where we're going. And the step that we're going to take is we're just going to add row 1 to row 3. Don't need to change anything about it. So row 1 still is what it is. 1, -1, 2, and -3. Row 2, still that new updated row 2 is 0, 3, -5, and 6. And row 3 is going to be different. So we're going to add row 1 to row 3. As we do that, 1 plus -1 is 0. That's nice. And -1 plus 2 is 1. And 2 plus -3 is -1. And -3 plus 7 is going to be 4. So I'll just check. Yep, those are the numbers I got. Awesome. All right, next step would be to, again, we're working our way towards getting a 0 here. So we're going to eliminate y from the third row. Now I'm going to work with row 2 and row 3 at the moment. Now the thing I'd have to do, if I were to add these two things together, I'd probably, we could multiply this by 3, or we can multiply this by 1/3, or -3 and or -1/3, make it go away. Let's try multiplying this, the bottom one, by -3. So we're going to go, we're going to take row 2 as is, plus -3 times row 3, and see what that does for us. Okay, so new matrix is going to be over here. Row 1 doesn't change. 1, -1, 2, -3. Row 2 staying the same. 0, 3, -5, and 6. Row 3 is going to be the different one. So if I multiply these by -3, add them to row 2. So -3 and 3 is going to be 0. Well, this was a 0 to begin with, by the way. So that's a 0. -3 times -1 is going to be +3. Add that to the -5, we're going to have -2. And the -12 plus a 6 is going to be a -6. So we're getting closer. Now this would be in echelon form, kind of. You could probably, at this point, if you're solving a system, you could say, oh, hey, -2z equals -6. I'm going to solve for z. It's 3. Plug it back in. Solve for y. Plug it back in. Solve for x. Okay. But again, for the sake of practice and putting this into the correct row echelon form, we need ones on the main diagonal. So at this point, because I don't need to rearrange any more of these equations, I just want to change how they look. And remember, one of those elementary row operations is to multiply a row by a constant. So if I need a 1 to be right here in row 2, I'm going to multiply row 2 by 1/3, if that makes sense. So I'm going to take 1/3 times row 2. At the same time, because I think I can see this happening, I'm also going to work with row 3. So row 3, I need a 1 right here to make this row echelon form. So I'm going to multiply row 3 by -1/2, which will give me a positive 1 there. So -1/2 times R3 and 1/3 times R2. Change those up. So row 1 still the same. 1 -1, 2 -3. Row 2 is now going to be 0, 1 -5/3, and 6 times 1/3 is going to be 2. And then row 3, 0, 0, there's no change. -1/2 times -2 is +1. -1/2 times -6 is going to be +3. So there I would now have my system in row echelon form. Okay, if it's in row echelon form, now again I was told to solve the system. So at this point I know that z is equal to 3. So as I'm finding my ordered triple, 3 is the answer for z. Okay, so I'll take 3, plug it back in for z, and solve for y. Just think about that. 3 times -5/3 is going to be -5. So this is going to be y minus 5 equals 2. Well, what minus 5 equals 2? That's going to be 7. So 7 is going to be the value of y. Okay. Now I plug those both into this equation, so I got, think of it this way. I'm going to have x minus y, which is 7, plus 2 times z, which is 2 times 3 is 6. So x minus 6 plus 7 equals -3. So that means that x must be -2. This is going to be -1, -2 plus -1 is going to be -3. So -2 would be the x value. So again, that's a lot of work to work through this by hand with matrix row operations, but it's doable. And again, if you are somebody who's going to be a math major or study math in depth in college, you'll probably take a course called linear algebra, and there will be a significant amount of matrix operations and things like this that will happen in linear algebra. So if you're headed that way, awesome. You've seen this once before. If you're not, this is a warning to never take that course. Just kidding. It's great. So that is finding row echelon form to solve a system.